Okay? Now, subnet mask can be drawn in two different ways. Okay? You can write it out explicitly like this, or you can have this right here, the slash notation. Well, a 255.255.255.0 looks like this in binary. You have a 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. That's 16, 17, 18, 19, 20, 21, 22, 23, 24, and that is their slash 24 notation. Okay? So if you have that there, again, easy to say, you know, where the ones stop, where the zeros begin, that's where I'm drawing my line. And that happens to be from the third item. So if I draw my line there, I belong to the 1011 network. You guys see that? Very simple for an easy class C address, right? Well, if I draw the line here for a slash 24, that's the same thing, slash 24. So now I know that I'm on different networks, the 1011, 1012, 1013. Each network is going to have its own separate broadcast, okay? Now, when I think about the host bits here, okay, notice that 34, 101134, and that 101137, they're using the same subnet mask. So by default, if I try to send anything from host A to host B right here, I know that I belong to the same network, therefore, do not send this to my default gateway whatsoever. I already know how to get on my same network segment. And I technically can use a broadcast for things like neighbor discovery, right? But if I try to send to somebody else over here, notice if I check my system, right? I'm a source of a 101134 with this subnet mask. If I'm going to this destination here, again, the destination, I don't care what the subnet mask is here. I just look at this here and I say, hey, is that the same as this guy? Okay? They belong in separate networks, so here I'm going to send it to my default gateway. Let my router make the routing decision. Okay? That's basically it. And again, I'm just drawing out the 255.255.255.0 one time. Again, just so you know that that's where I'm drawing my line. If it happened to be that this is 255.255.255.240, okay, that basically tells me there's 1, 2, 3, 4, 1, 2, 3, 4. Okay? 128 plus 64 equals 192, plus 32 equals 224, plus 16 equals 240. So now what I'm going to do here, if it was in fact a 240 right there, I would then draw my line right here. Okay? And if that was the case, I would have to draw 32 in binary. Well, 32 in binary looks like a 34, 0, 0, 1 for the 32-bit, 0, and then I need 2 more, right? 0, 0, 1, 0. Okay? So that's where I'm drawing my line. Well, if I match all of this up, again, match the 0, that means 0. Match the 0. Match the 1. Match the 0. Okay? And then all these are just host bits here. I don't care what they are. That means this guy belongs to a 32 dot. Okay? Because all I'm doing with the subnet mask is matching it up. Hey, if I draw a 10 right here, that's a 0, 0, 0, 0, 1, 0, 1, 0. Well, if I match all 8 bits here, what are you going to get? A 10. Right? If I match all 1s, I mean a 1 here, 0, 0, 0, 0, 0, 0, 0, 1. If I match all 8 bits, what am I going to get? 0, 0, 0, 0, 0, 0, 0, 1, which is a 1. Okay? So that's why I don't particularly draw out all these 1s and 0s in binary anymore. Okay?